You have probably grabbed a bottle of Head and Shoulders at some point in your life. Maybe you were dealing with those pasty white flakes on your shoulders. Maybe a friend recommended it. Maybe it was just on sale. But here's something weird. Almost nobody reads the label. If you flip that bottle around and squint at the active ingredients, you'll see something called zinc pyrithione. Pyrithione sounds like something a supervillain would synthesize in a secret lab, but it's actually one of the most quietly fascinating molecules in your bathroom cabinet. And today, we are going deep on it. Zinc pyrithione isn't just some random chemical thrown into your shampoo. It's a precisely engineered compound with a 6-year scientific history, a surprisingly complex mechanism, and applications that range from shower to construction coatings to anti-fouling paint on ships. So, whether you're a chemistry nerd, a skincare fanatic, or just someone who's tired of dandruff, buckle up. This one is going to be good. Let's start with the basics. What is zinc pyrithione? Chemically, it's a coordination complex. Don't let that phrase scare you. It just means it's a metal, zinc to be specific, bonded to a specific organic molecule called pyrithione, which is a derivative of pyridine 2-thiol. The full name is bis-2-pyridinathiol 1-oxide zinc. You can see why they just call it zinc pyrithione. It was first synthesized in the 1930s, but it only really came to prominence in the 1960s when researchers discovered it had powerful antifungal and antibacterial properties. Procter & Gamble began incorporating it into Head and Shoulders in 1961, and for the next 6 decades, it became the gold standard treatment for seborrheic dermatitis, which is just the medical term for what most of us call dandruff. In its pure form, zinc pyrithione is a white to white off crystalline powder. It barely dissolves in water, which is actually one of its engineering challenges. Getting it to play nicely in a water-based shampoo formulation requires some clever chemistry. It's usually added as a 1% or 2% concentration in over-the-counter products. Small amounts but incredibly effective ones. Zinc is one of the most biologically essential trace metals in the human body. It's involved in over 300 enzymatic reactions, your immune system, DNA synthesis, wound healing, name it. Zinc is everywhere. But when you pair zinc with pyrithione ligand, you create something with a very specific, very targeted ability to disrupt certain types of microorganism biology. And that brings us to the real question. How does it actually work? Okay, here is where it gets genuinely fascinating. To understand how zinc pyrithione works, we first need to talk about something living on our head right now. Don't panic. It's just a fungus, specifically a genus of yeast called Malassezia. Almost every single human on the planet has Malassezia on their skin. It's a normal part of your skin microbiome. It loves oil. It feeds on the fatty acids in sebum, which is the skin's natural oil. Normally, it's perfectly harmless, but in some people, under certain conditions like stress, hormonal changes, weather shifts, oily skin, etc., Malassezia overgrows, and when it does, it irritates your scalp, triggering an inflammatory response that causes the skin to shed more rapidly than normal. Those shed skins clump together with oil, and you know the rest, dandruff. Dandruff occurs. You now have dandruff. So, how does zinc pyrithione stop this? For decades, scientists believed it primarily worked by disrupting the fungal cell membrane. That's still true, but recent research, particularly from the early 2020s, has revealed something much more precise. Zinc pyrithione specifically inhibits an enzyme called squalene epoxidase, a key enzyme that malassezia needs to synthesize its cell membrane stirrers. Without functional membrane stirrers, the fungal cells become leaky and die. But there is more. Zinc ions from zinc pyrithione also interfere with ion cipher cluster proteins inside the microorganism cells. These proteins are essential for energy metabolism. Essentially, zinc pyrithione cuts off the fungus's power supply while simultaneously destabilizing its host. And critically, this mechanism is quite selective. Zinc pyrithione affects fungus and certain bacteria much more readily than it affects human cells, which is why you can safely leave it on your scalp without eating through your skin. The selectivity comes down to molecular targets. Human cells have different membrane compositions and different enzyme variants. Zinc pyridione's primary enzymatic targets don't have close functional analogs in human biology at the concentrations used in cosmetics. It's a bit like a key that only fits certain locks, and yours happen not to be among them. Fortunate enough, you know. Now, here is where the story gets broader than most people realize. Zinc pyrithione isn't just a dandruff ingredient. It has a surprisingly wide range of industrial and medical applications. The most famous use, obviously, is in scalp and skincare. Zinc pyrithione is the active ingredient in dozens of anti-dandruff shampoos, including Head and Shoulders, Sesame Blue, and many other salon brands. It's approved by the Food and Drug Administration as an over-the-counter drug for treating dandruff and seborrheic dermatitis. It's also found in some face washes and body soaps targeting skin conditions like tanner vescala, another malassezia-related issue causing patchy, discolored skin. Ships, offshore platforms, and underwater structures have a big problem. Marine organisms like algae, barnacles, mussels, etc. love to colonize any surface submerged in water. This by falling dramatically increases drag on ships, reducing fuel efficiency and increasing maintenance costs. Zinc pyrithione was widely used as an anti-fouling agent in marine paints because of its efficacy against these organisms. However, this is important, very important actually. There have been growing environmental concerns about zinc pyrithione entering aquatic ecosystems through paint runoff. The European Union has restricted some of its anti-fouling applications, and the regulatory landscape is evolving. Zinc pyrithione is used as a biocide in paints, coatings, and textiles to prevent mold and mildew growth. Can you recall those outdoor furniture cushions that resist mold? Some of them are treated with zinc pyrithione-based compounds. Zinc pyrithione is sometimes used in very low concentrations as a preservative in cosmetics and personal care products to prevent microbial contamination in the product itself. Now, let's talk about something that genuinely shook the skincare industry a few years back. In 2022, the European Union's Scientific Committee on Consumer Safety, SCCS, concluded that zinc pyrithione could not be considered safe for use in rinse-off cosmetic products. And by rinse-off cosmetic products, we're talking about shampoos, body washes, anything that you use and then wash down the drain. This led to restrictions across the European Union and some other regions. The primary concern was reproductive toxicity. Animal studies showed that zinc pyrithione could affect reproduction and development at higher doses. The SCCS evaluated the potential systematic exposure, especially from repeated use of shampoos, where zinc pyrithione could absorb through the scalp, and they concluded that the risk margin was not comfortable enough for a cosmetic product. Additionally, there was also an environmental concern. Zinc pyrithione breaks down in water into byproducts that can be harmful to aquatic life, and cumulative discharge from millions of daily shampoo users adds up. The industry has been scrambling. Major brands have reformulated their products for the European Union market. Some have switched to alternative active ingredients. In the US, zinc pyrithione remains FDA approved and widely used. The FDA's safety assessments have reached different conclusions, partly because the US uses different risk frameworks and different exposure modeling assumptions. Ultimately, as a consumer, being informed is more powerful than being afraid. If you're concerned, you can choose zinc pyrithione-free formulations. If you're in a country where it's approved and you use it occasionally, the risk profile is very different from someone bathing in it daily. Now, let's talk about personal safety because this is what most of us care about. For the vast majority of people, 1 to 2% of zinc pyrithione in a rinse of shampoo used a few times a week poses very little risk. Decades of use by hundreds of millions of people have not produced signals of widespread harm. In clinical dermatology, it's still considered a first-line treatment for mild to moderate seborrheic dermatitis. Pregnant individuals should stay away from zinc pyrithione. Given the reproductive toxicity data from animal studies, many dermatologists suggest erring on the side of caution during pregnancy. People with compromised skin barriers also should not use zinc pyrithione because more absorption through broken or severely irritated skin is possible. And also children. The European Union recommends avoiding leave-on products with zinc pyrithione for children under 3 years old. In rare cases, zinc pyrithione can cause skin irritation or allergic reaction. If you find your scalp more irritated after using a zinc pyrithione shampoo, then you need to stop using it and consult a dermatologist. Zinc pyrithione should not be used near the eyes or ingested. It's a biocide, and in toxicology, concentration and exposure are everything. So what does the future look like for zinc pyrithione? Chemists and formulators are working on encapsulated zinc pyrithione, micro and nano encapsulation technologies that allow more targeted delivery to the scalp, potentially improving efficacy while reducing the amount needed and therefore reducing the environmental safety concerns associated with higher doses. As the European Union has moved to restrict zinc pyrithione in rinse-off products, other regulatory bodies will be watching the science and potentially following. The scientific community continues to study the compound's biodegradation pathways, metabolites, and long-term ecological impacts. The most exciting frontier is probably the microbiome angle. As we learn more about the complex ecosystem of organisms that live on our skin and scalp, we may be able to develop treatments that modulate the microbiome. Rather than bodily killing fungus, we may shift the balance. Zinc pyrithione research is feeding into this broader microbiome science. Early stage research has explored zinc pyrithione potential in wound care, in acne treatment, and even in addressing certain biofilm-related infections. None of these are mainstream yet, but the scientific curiosity is very much alive. Here's what I love about zinc pyrithione. It's this totally ordinary molecule, something you've literally been washing your hair with probably for years, that turns out to have this rich, layered scientific history, a story of discovery, of careful mechanism research, of industrial application, and now of regulatory reckoning. It reminds us that the most interesting things in life are often hiding in plain sight, or in this case, hiding in a blue and white bottle on the second shelf of your shower. Science isn't just in laboratories and academic journals. It's in your bathroom, in your morning routine, in the products that quietly make your life a little more comfortable. Next time you pick up a bottle of anti-dandruff shampoo, I hope you look at these two words: zinc pyrithione. And think, there's a whole world in there. A 6-year story of chemistry, biology, regulation, and yes, your scalp health. That's worth knowing about. Thank you for watching and see you in the next video.